Hello, ladies and gentlemen. Today we have a very scary looking integral here. The integral from 0 to infinity, the natural log of the absolute value of the natural log of x, all divided by 1 plus x into bracket 4 plus the natural log of x squared dx. This problem I got it from Sir Fao Ler. I don't know how to pronounce the name. Actually, this guy is really good in mathematics. Then let's see how we are going to evaluate this improper integral. Before we proceed, we need to take note of an integral property, which is really going to be very cool here. We have the integral from 0 to infinity of a function of x dx. We can break this down as the integral from 0 to 1 of this function of x dx plus the integral from 1 to infinity of this function of x dx. The reason why I'm making use of this property here is because of this absolute value function. Let us talk about this absolute value function of the natural logarithm of x. We all know that the absolute value of the natural logarithm of x is going to be negative natural log of x, where 0 is less than x, right, and x is less than 1. Okay, and again, the absolute value of the natural logarithm of x is going to be the natural log of x in positive form, where x is greater than 0. And from here we can see that the limit of integration from this second part here is from 1 to infinity. So for here, this we are going to make use of this condition. Then let's go back to the problem. The integral, let's call it I. So we have here I is equal to the integral from 0 to infinity of the natural log of the absolute value of the natural log of x all over 1 plus x into bracket 4 plus the natural log of x squared dx. And with the integral property here, we break this down as the integral from 0 to 1, the natural log of the absolute value of natural log of x all over 1 plus x into bracket 4 plus the natural log of x squared dx plus then the integral from 1 to infinity, the natural log of the absolute value of x all over 1 plus x into bracket 4 plus the natural log of x squared dx. Okay, now let us make use of these conditions here. You know, I is going to be the integral from 0 to 1. Right over here, the absolute value of this natural logarithm of x is negative because of the limit or boundary of integration. So we have the natural log of the negative natural log of x all over 1 plus x into bracket 4 plus the natural log of x squared dx, then plus the integral from 1 to infinity of the natural log. This will become positive, right? Then all over 1 plus x multiplied by 4 plus the natural log of x squared, and here we have the x. But for this part here, we can make a substitution. For this integral here, we can let x equals 1 over x. Actually, these x are not equal. Let me just tell you, they just serve as dummy variable. Okay, you know, the x here, if you differentiate both sides, is going to be negative 1 over x squared dx. What about limit of integration? We all know that this new x here is also equal to the reciprocal of this x here. So when we talk about the limit of integration, when x tends to 1, that will also tend to 1, but when x tends to infinity, the new x will tend to 0. So here we have I is equal to the integral from 0 to 1 of the natural log of negative natural log of x all over 1 plus x into bracket 4 plus the natural log of x squared dx. And here we have plus the integral. Okay. Oh, God. Now from here, the x here is negative 1 over x squared dx, and we have a negative sign. But let us put everything first. Here we have from 1 to 0, right? Then the natural log of, from here, this will be the natural log of 1 over x from here. Then all over, this is going to be 1 plus 1 over x, right? Which simplifies to just 1 plus x all over x, just like that. Then 4 plus the natural log of 1 over x squared is still the same as the natural log of x squared. Then here we have to multiply by the negative 1 over x squared, then dx. This is the multiplication sign in place. And from here we have I is equal to the integral from 0 to 1, the natural log of the negative natural log of x all over 1 plus x into bracket 4 plus the natural log of x squared dx, then plus, with this negative sign we can switch the limits and we have from 0 to 1. The natural log of 1 over x is the same as negative natural log of x, right? Then all over, we have to multiply the whole of these denominators together. But right over here, x squared will multiply this, and we just have to cancel out the x. We have just x into bracket 1 plus x, then 4 plus the natural log of x squared, then dx. Okay, from here we can combine this integral together because we have the same limits of integrations, right? So here I is going to be equal to the integral from 0 to 1. Here the common denominator here is x, 1 plus x, 4 plus the natural log of x squared. And when you divide this by this, we just have x multiplied by the natural log of negative natural log of x, plus when you divide this by this, we just have 1. Then multiply by the natural log of negative natural log of x. Here we have the x, and here we can factor out the natural log of negative natural log of x from up. We have here the natural log of negative natural log of x into brackets. We know we have just x plus 1. Then right over here we have all over x into bracket 1 plus x, 4 plus the natural log of x squared dx. From here we cancel out this. You can see we have some nice cancellations from here. We have I is equal to the integral from 0 to 1, the natural log of the negative natural log of x all over x into bracket 4 plus natural log of x squared dx. Okay, now we can see we can make a substitution from here. We are going to let the negative natural log of x equals y. So the natural log of x will be negative y. Here differentiate both sides, we get here the x over x. This is equal to negative dy. Okay, this x here, if we don't want to write this x here, we can put it here, right? Since we have the x over x is equal to negative dy. So the target integral I is going to be integral from here, limit. We have when x is approaching 0 here, the lower limit here will be approaching negative natural log of 0, which is approaching infinity. And when x is approaching 1, we have 0. And here we have the natural log of y, then all over, here 4 plus y squared, Okay, then here we have the dx over x, which is negative dy, right? And from here, with this negative sign, we can switch from 0 to infinity, the natural log of y, then all over. If you factor out 4 from this denominator, we have 1 plus y squared over 4 is the same as y over 2 squared, right? Then dy. So let's make a substitution one more time. We are going to let y over 2 equals x. Let's go back to x word. And here we have y is equal to 2x, then dy is equal to 2 dx. So the target integral I is going to be the integral. We still have the same limit of integration, but this 4 here is moving out, and that 1 over 4 times these 2 here, we just left with 1 over 2. Then from 0 to infinity, the natural log of, here we have 2x all over, here we have 1 plus x squared dx. Wow. So from here, this integral is really looking very familiar. We have to make use of the properties of natural logarithm. We have here natural log of 2 over 1 plus x squared dx plus 1 over 2, the integral from 0 to infinity of the natural log of x all over 1 plus x squared dx. Okay, now if you check, I think the video we posted here, I think 2 days ago, 3 days ago, we proved that the integral from 0 to infinity of the natural log of x over 1 plus x over dx is equal to 0, right? So here we have I is just equal to the natural log of 2 over 2, then the integral from 0 to infinity of 1 over 1 plus x squared dx, and from here we have the natural log of 2 over 2, then we have the arctan of x from 0 to infinity. So from here, our target integral I is going to be the natural log of 2 over 2. Then we can make use of the limit. So when we substitute the upper limit, we have the integral, the arctan of infinity minus, then the lower limit, the arctan of 0. And from here, we get the natural log of 2 over 2 multiplied by the arctan of infinity is pi over 2. And here we have to simplify as pi times the natural log of 2 all over 4. And this is the right answer to the problem. We can see that the integral really come out to be a very nice integral with a very neat and beautiful closed form, right? Thank you for watching. Please kindly subscribe to my channel. Also like, comment, and share. Please share this video so that others may see my handwork. Thank you.